So today we will be discussing about the analogies in transport phenomena. So the analogies that has been found is transport phenomena involves the movement of mass, energy, and momentum in physical systems. The main types are mass transfer, movement of chemical species in a mixture, heat transfer, transfer of thermal energy due to temperature difference, momentum transfer which occurs by the flow of fluids in and related forces. And the analogies comes as in system involving liquids or gases, however, it is very difficult to eliminate convection from the overall mass transfer process. Mass transfer by convection involves the transport of material between a boundary sources. There are two different cases of convective mass transfer. And the equation governing convective mass transfer in a single fluid phase are one is Q by A, which is equal to Q is equal to H into Ps minus Pm. So this is one governing equation, and the other is Na is equal to Kc Cas minus Ca. So this is all the governing equations, and significant parameters in convective mass transfer are dimensionless parameters which are used to correlate convective transfer data. In momentum transfer, Reynolds number and friction factor play a major role. And then the mass diffusivity, molecular diffusivity on the three transfer forces, mass diffusivity DAB is equal to, and the momentum diffusivity is given as V by alpha, Cp mu by K, and one is momentum diffusivity divided by thermal diffusivity, which gives the Prandtl number. And the analogous number in mass transfer is the number given as the Schmidt number, which is given by V by DAB, and the Lewis number it is given by thermal diffusivity by mass diffusivity, which is given by alpha by DAB, that is momentum diffusivity by K rho Cp DAB. Analogies between the transport phenomena are mathematical analogies, physical analogies. Despite different physical quantities, the governing equations and mechanism often show strong analogies. And mathematical analogies, the given by Fick's law, Fourier's law, Newton's law, all comes under the linear relation between flux and driving force gradient. Physical analogies are given by the mechanical comparison, diffusion mass transfer, conduction heat transfer, viscous flow, and momentum transfer. And dimensionless numbers in transport phenomena are Reynolds number, Prandtl number, Schmidt number. Analogies in practical applications. Use of analogies to simplify complex systems in engineering or chemical reactions, heat exchangers, pipelines. All these come under the practical applications of the analogies. And advantages of using analogies are simplification. It reduces complexity in analysis and design. Efficiency, it is helping in problem solving. And then interdisciplinary application facilitates understanding across different domains. So these are some of the advantages using the analogies. And now we will come across the limitation of analogies, which is approximation. It is not always precise, and then context dependent, may not apply in all scenarios, and then non-linearity, which breaks down in non-linear systems. And and the overview of momentum transfer, which comes under the moment of in fluids, fluid flow, shear stress, and the key equation which is given is Newton's law of viscosity. Mass transfer by convection involves the transport of materials between a boundary suitcase boundary surface such as solid or liquid surface and a moving fluid between two relatively invisible moving fluids. And then there are two different cases of convective mass transfer. Mass transfer takes place only in a single phase, either in a two form. Okay, thank you for listening.